Welcome to the third installment of the Reliability video series. A key step to selecting the appropriate travel time reliability analysis tool is to have a well-defined scope of the problem being studied. Once the temporal and spatial analysis extents are established, the next step is to align the objectives of the study with the capabilities of the various travel time reliability analysis tools. In this module, we'll discuss how to identify the appropriate level of detail required for the analysis and align the goals of the evaluation with the tool capabilities to support selection of an effective tool for the analysis. Certain traffic analysis tools are designed for greater level of detail than others. Analysts need to consider the scope of their project, whether it's a highway segment or regional network, before selecting tools to ensure they will achieve the granularity of output performance measures they desire for the problem statement, while aligning the level of effort required for the analysis within reasonable limits. Tool types that we'll be discussing in this module range from sketch planning level to microsimulation. Typically, analyses that focus on spot locations or segments of a highway require more detailed and data-intensive tools to provide meaningful results. For instance, more robust analyses, such as those that use microsimulation, require a wider selection of data than sketch-level evaluations. Generally, planning-level tools provide reliability measures at a lower level of confidence and are more appropriate for comparative analyses between project alternatives, whereas analytical and simulation tools can provide much more granular travel time outputs. The more demanding tool types allow for more comprehensive reliability results to be developed and are intended to provide answers to detailed design questions. Sketch planning methodologies produce general order of magnitude estimates of travel demand and traffic operations in response to transportation improvements, allowing for the evaluation of specific projects or alternatives without conducting an in-depth engineering analysis. Sketch planning tools use very limited geometric and traffic demand inputs, such as demand to capacity parameters, to predict recurring and non-recurring performance indices. Generally, sketch planning tools output a set of key reliability measures that can be used to estimate wider travel time distributions. Based on the coarseness of inputs and outputs, appropriate applications may include prioritizing analysis locations for investments during high-level planning efforts. SHARP2 solutions, developed by the Transportation Research Board in partnership with AASHTO and FHWA, contain guidance and tools applicable to planning-level reliability analyses, such as Project C11. Based on the coarseness of inputs and outputs, appropriate applications may include prioritizing analysis locations for investments during high-level planning efforts. As tools progress towards the analytical and deterministic scale, the level of effort and robustness of the evaluation increases. The inputs may incorporate weather, special event traffic patterns, work zones, and other data elements to capture demand and capacity variation. The underlying computational methods for segment and corridor travel times are also more advanced than sketch planning models, thus providing more confidence in the output results. Including inputs such as non-recurring factors, facility capacity, and traffic demand, analytical and deterministic tools provide travel time estimates for a vast number of possible travel scenarios. The analyst can typically access the raw travel time information for each scenario, as well as post-processed reliability measures and distributions over the reliability analysis period. The analyst uses these comprehensive reliability measures and visualizations to convey reliability performance. SHARP2 Project L08 provides guidance and tool options for analysts looking to use deterministic reliability tools. Analytical and deterministic tools are helpful for analyzing the performance of isolated or small-scale transportation facilities. Since travel time performance calculations are typically handled at the segment or link level, however, analytical and deterministic tools are limited in their ability to analyze network or system effects of various operating scenarios. Traffic simulation tools are the most granular of the different tool types and are necessary to handle traffic interactions across a transportation network. The use of simulation tools opens up the door to capture network-wide impacts of traffic incidents, work zones, and other disruptive events that are found across a transportation system. The method of performing dozens or hundreds of scenario simulations is analogous to the analytical and deterministic method of processing hundreds of facility travel time scenarios. However, the increased level of effort of generating various operating scenarios and the network impacts on capacity and demand are substantial, considering the increased detail associated with simulation modeling tools. There has been continued development of additional tools to assist with generating modeling scenarios for direct input into the simulation model, as well as tools to process the extensive model outputs. The analyst should be aware of advancements in tool extensions as they continue to mature. SHARP 2 Project L04 provides comprehensive guidance on incorporating reliability into simulation models and discusses methods and tools to facilitate the analysis process. Because of the availability of vehicle traversal times as model outputs, traffic simulation tools are often relied upon to provide detailed results on various transportation design options. Coupling simulation tool capabilities with travel time reliability analysis procedure provides decision makers with a highly detailed and thorough assessment of predictive operation performance. The power of using simulation tools in a traffic reliability analysis derives from the close relation of the output data to what travelers actually experience during a trip. Mesoscopic and microscopic traffic simulation models are particle-based models that produce individual vehicle or particle trajectories. The availability of trajectories in the output of a simulation model enables construction of any level of travel time distributions of interest. The key building block for producing measures of reliability in this framework consists of particle trajectories and the associated experienced traversal times through entirety or part of the travel path. With the appropriate methods and tools to process extensive microsimulation outputs, the analyst is capable of producing highly robust and informative results on travel time performance. Methods for producing comprehensive and useful visualizations from complex output data, such as that generated from simulation tools, will be covered later on in the video series. In this module, we've tied the objectives and scope of the study to potential tool types and necessary level of detail to conduct the travel time reliability analysis. In the next module, we'll examine methods and sources that can be used to collect the appropriate data for your reliability analysis.